In this video, we're going to look at how to solve a very basic trig equation here, where 7 sine of theta minus 1 equals to 2. We're going to find the solutions in the interval from 0 to 360, including 0 but not the 360. At any point, if you want to try to work this out, go ahead. I'm going to go over some basic ideas that, just in case you don't know, I'm going to use the reference angle technique to solve this problem. But like I said, you can go ahead and try it on your own. So I'm going to talk a little bit about the reference angle. That's the method I'm going to use. We have an angle theta in standard position. So any angle that has its initial side along the positive x-axis, so that'll be this right here. And then the terminal side could be anywhere. First quadrant, second quadrant, third quadrant, fourth quadrant. And we're looking at counterclockwise direction, so that means the angle is positive. We could go clockwise. The angle would be negative. So here's the situation. If you have an angle in standard position and you can find a point on the terminal side of the angle, in this case I have the point xy, and the distance from the origin to that point, that's r, right here. If you know that point and that distance r is positive, then you can find the trig function values of that angle. Sine of theta would be the y component over r. Again, r is always positive. The cosine of that angle would be the x component of that point over r. The tangent of that angle would be the y component over the x component. So keep in mind that in quadrant 1, the first component of any point is always positive. The second component is always positive. And of course, the sine, cosine, and tangent have the reciprocals. They're going to have the same components. The cosecant would just be r over y. The secant would be r over x. The cotangent would be x over y. So you can see in the first quadrant, because r is always positive, all the trig function values of all the 6 functions rather, are all positive. Now over here on quadrant 1, or quadrant 2 I should say, we go to the left, so the first component is negative. If we're up here, this is positive. Now if the terminal side lies somewhere in quadrant 3, we go to the left, so the x is negative. We go down, so the y is negative. And then if the angle is somewhere over here in quadrant 4, we go to the right, so the x is positive. Then we go down, the y is negative. So those signs of those points will determine whether you have a positive value for the trig function value of that angle or a negative. So that's something that you need to be aware of to solve these types of problems. And the other thing you need to be aware of is this. I have the angle theta in standard position, and this angle right here is the reference angle. Now if I draw the angle somewhere over here in quadrant 3, say this is theta, then this angle right here would be the reference angle associated with angle theta, right there. If I draw the angle somewhere over here, theta say goes this way, then this angle here is the reference angle. So the reference angle is the smallest acute angle. It's got to be positive that angle makes with the x-axis. Here, reference angle here, positive. Reference angle here is positive. Reference angle here is positive. So what we need to know then is this. Have it right here. The sine or the cosine or the tangent, regardless of what you're looking at, of angle theta will always be plus or minus the sine or cosine or tangent of the reference angle. So if you're given, say, you look at the sine of, say, 135 degrees. So let's say this is 135 degrees there. Then the reference angle would be 180 minus 135. This would be 45 degrees. The sine of 135 will always be the same value as the sine of the reference angle, which is 45. Could be plus or minus, so it's going to depend on where the angle lies. But in this particular case, Just to double check it here with the calculator, the sine of 135 is 0.707, and let's look at the sine of the reference angle, 45. Arcsine, so it's sine of 45. And notice it's the same value, Let's look at the, say, the sine of 315. That angle is in the fourth quadrant. If I compute that out, I get a negative. And then if I look at the sine of the reference angle, okay, we're in quadrant 4. So this angle, that's 315. The reference angle is 45 degrees. So if I enter 45, now you should know that the trig function value of any acute angle is always going to be positive. So if I hit enter, I expect a positive number. In quadrant 315 is in quadrant 4. So that point on that terminal side would be positive x and negative y. So I expected a negative there. But notice if I hit enter here, the absolute value of those is the same. Notice it's a negative 0.707, a positive 0.707. So the thing to remember again is this thing right here. If you have the function value of theta, and here I'm letting that f represent any trig function, could be sine, cosine, tangent. This will always equal to plus or minus the value of the reference angle. So tangent here, or sine, and sine, cosine, and cosine. So the only thing you have to remember or keep track of is where is the tangent or the sine or the cosine positive. And again, that's going to depend on the quadrant because we're looking at the points x, y, and r. We're going to use those values to determine the value for that particular trig function. And one of the other things we need to know again is know your 30-60 right triangles. This is the right angle here. The sine of 60. So from this perspective here, look at this right here, is opposite over hypotenuse. So that's square root of 3 over 2. The cosine of 60 from this perspective here, orientation, adjacent over hypotenuse, that's 1/2. Tangent of is the opposite over the adjacent. We get this. And then from this perspective here, the sine of 30, opposite over the hypotenuse, that's 1/2. The cosine, adjacent over the hypotenuse, square root of 3 over 2. The tangent, opposite over the adjacent, is 1 over the square root of 3, simplify it. Also know your 45-45 triangle. So this is 45 degrees, and this is 45. This is 1, and this is 1. This is the square root of 2. So the sine of 45 degrees is 1 over the square root of 2, or simplify that, square root of 2 over 2. The sine, or cosine I should say, at 45 degrees. Adjacent over the hypotenuse, that's 1 over the square root of 2, or simplify that, rationalize it, square root of 2 over 2. And of course the tangent at 45 degrees is opposite over the adjacent, that would be 1 over 1, which would be 1. And also keep in mind that these can be multiplied by any positive value, and that ratio will still hold. Okay, so this could be 2, 2, and let's go to 2 times 2. So now let's go to the problem. And this is no different than solving something like this. 7x minus 1 is equal to 2. Linear equation in basic algebra. We add 1 to both sides. We get 7x is equal to 3. Divided by 7. So if I was solving a linear equation here, x would equal to 7, or 3 over 7 I should say. Same idea over here, except we're going to do a little bit more for trig equation here. But you're going to use the same types of procedures. You can use a quadratic formula depending on what type of equation you have. So in this case, we're going to have sine of theta. We brought this over and divided by 7, so I got sine of theta is equal to 7 over, or 3 over 7. Add 1 and 1, divide by 7, we get this. So now we're looking for solutions in the interval from 0 to 360. So here we don't have an exact solution. If this had come out to the square root of 2 over 2, then we know that theta is equal to 45 degrees and 135. So here we have to use the calculator. So basically what I have then is I'm going to use the sine inverse of 3 over 7. So taking sine inverse of both sides here, I get theta is equal to. And now when you're working these kind of problems, make sure you know what your calculator is set to, whether it's set to degrees or radians. So here we're dealing with degrees. So double check. I've already done this, but radian, degrees. So mine's in degrees, so I'm okay. And then I want sine inverse of 3 over 7. So sine inverse, I get my inverse function, 3 divided by 7. Hit enter. And this tells me that the angle is 25.37 and so on. I'm going to round this off to 1 decimal point. So okay, theta is equal to 25.4. Round it out to 1 decimal point. Now you can use this as your reference angle now. Now normally on these, you're going to have 2 solutions in the interval, especially if you have the angles on a particular quadrant, 1, 2, 3, or 4. So here's a situation. So let's say my reference angle here is 25.4. So you can draw a diagram over here and say make this your reference angle. So to say this is theta prime. So if this is a reference angle, then that's one solution. Then the other solution will be this angle here. So that's 180 minus 25.4. And if you do that subtraction and round it off to 1 decimal point, then we get another solution of 154.6. And these are in degrees. So the solution to this equation, or the solutions in this case, are 25.4 degrees and 154.6 degrees. Now I want to point out to you that if an equation, a trig equation, has one solution, it's always going to have an infinite solution, because you can add a multiple of 360 to 25.4 and that's going to work. Or you can add a multiple of 360 to 154.6. So this could be plus 360 degrees, or any multiple, and that's going to work. But in this case, we're looking for solutions only in the interval from 0 to 360. Because these functions are periodic, so the solutions repeat. But we only want them in the interval from 0 to 360. So let's just do a quick check here. Let's look at the sine of 25.4 and then the sine 154.6. We get the same value. Now if you look at the original equation, sine theta is equal to 3 over 7. So let's see if it checks with that. And it's going to be a little bit off because of the rounding off. But let's see, 3 divided by 7. You can use pretty close, 42.4285. And again, because of the rounding off, I could round off these answers to more decimal points and be a little bit more accurate. And they do fall in the interval. So when you're using that reference angle, just make sure that you put it in a place where that particular function value is the correct sign, positive or negative, depending on the quadrant. Thanks for watching. We'll see you next time.